Hi guys, have a wonderful day. In this video talk about what is a 6G network, definition, features, and benefits. Hey guy, just 1 minute. InfoRx helpful to your tech life. Please subscribe our channel. If likes this video, give a thumbs up. Okay, let's go to the topic. 6G network enables high-speed, low-latency communication at a pace multiple times faster than 5th generation networks. A 6G network is defined as a cellular network that operates in untapped radio frequencies and uses cognitive technologies like AI to enable high-speed, low-latency communication at a pace multiple times faster than 5th generation networks. This article discusses the new generation of cellular data networks, 6G. It also explains the core functionalities of 6G and how it works. What is a 6G network? A 6G network is defined as a cellular network that operates in untapped radio frequencies and uses cognitive technologies like AI to enable high-speed, low-latency communication at a pace multiple times faster than 5th generation networks. 6G networks are currently under research and development, yet to be released. 6G is the 6th generation mobile system standard currently being developed for wireless communications over cellular data networks in telecommunications. It is the successor, or the next bend in the road, after 5G and will likely be much faster. The International Telecommunication Union, ITU, standardizes wireless generations every decade. Typically, they are denoted by a gap in the air interface, which signifies a shift in transmissions or coding. This is implemented so that older devices cannot be updated to the newer generations, since doing so would generate a limitless quantity of noise and spectrum pollution. Typically, subsequent generations, i.e., the next G, use much more sophisticated digital encoding that outdated computers cannot achieve. They depend on broader airwave bands that governments did not previously make accessible. Additionally, they have immensely complex antenna arrays that were previously impossible to construct. Today, we are in the 5th generation. The first standard for 5G new radio, NEAR, was developed in 2017 and is presently being implemented globally. According to a report titled, 6G the Next Hyperconnected Experience for All, the ITU will start work in 2021 to create a 6G mission statement. The standard will likely finish by 2028 when the first 6G devices are available. Around 2030, deployment will be close to ubiquitous. How will 6G work? The exact working of 6G is not yet known, as the specification is yet to be fully developed, finalized, and released by the ITU. However, depending on previous generations of cellular networks, one can expect several core functionalities. Primarily, 6G will operate by making use of free spectrum. A significant portion of 6G research focuses on transmitting data at ultra-high frequencies. Theoretically, 5G can support frequencies up to 100 GHz, even though no frequency over 39 GHz is currently utilized. For 6G, engineers are attempting to transfer data across waves in the hundreds of gigahertz (GHz) or terahertz (THz) ranges. These waves are minuscule and fragile, yet there remains a massive quantity of unused spectrum that could allow for astonishing data transfer speeds. Improving the efficiency of the free spectrum, current wireless technologies permit transmission or reception on a specific frequency at the same time. For two-way communication, users may divide their streams as per frequency division duplex or FDD, or by defining time periods, time division duplex or TDD. 6G might boost the efficiency of current spectrum delivery using sophisticated mathematics to transmit and receive on the same frequency simultaneously. Taking advantage of mesh networking has been a popular subject for decades, but 5G networks are still primarily based on a hub-and-spoke architecture. Therefore, end-user devices, phones, link to anchor nodes, cell towers, which connect to a backbone. 6G might use machines as amplifiers for one another's data, allowing each device to expand coverage in addition to using it. Integrating with the new IP, a research paper from the Finnish 6G flagship initiative at the University of Oulu suggests that 6G may use a new variant of the Internet Protocol, IP. It compares a current IP packet an IPv4 or IPv6 to regular snail mail, complete with a labeled envelope and text pages. The new IP packet would be comparable to a fast-tracked courier package with navigation and priority information conveyed by a courier service. 6G will rely on the selective use of different frequencies to evaluate absorption and adjust wavelengths appropriately. This technique will leverage the fact that atoms and molecules produce and absorb electromagnetic radiation at certain wavelengths, and the emissions and absorption frequencies of any particular material are identical. See more. What is GSM, Global System for Mobile Communications? Meaning, working, architecture, and applications. When will 6G become available? As mentioned earlier, the commercial debut of 6G Internet is anticipated to go live around 2030-2035. In addition to the ITU, the Institute of Electrical and Electronics Engineers, IEEE, a non-profit society for technology standardization, ratifies this dateline in its peer-reviewed paper titled, 6G Architecture to Connect the Worlds. The paper states, 2030 and beyond will offer a unique set of challenges and opportunities of global relevance and scale. We need an ambitious 6G vision for the communications architecture of the post-pandemic future to simultaneously enable growth, sustainability as well as full digital inclusion. While there have been some preliminary conversations to characterize the technology, 6G research and development, R&D, efforts began in earnest in 2020. The 6G flagship initiative combines studies on 6G technologies across Europe. Japan is committing $482 million to the expansion of 6G in the next few years. The country's overarching objective is to showcase innovative wireless and mobile technologies by 2025. In Russia, the R&D institution NIIR and the Skolkovo Institute of Science and Technology produced a 2021 estimate predicting the availability of 6G networks by 2035. American mobile providers are advancing their individual 6G innovation roadmaps. Importantly, AT&T, Verizon, and T-Mobile are spearheading the NextG Alliance, an industry initiative. In May 2021, the NextG Alliance initiated a technical work program to develop 6G technology. Why is 6G necessary? Given that the ink is yet to fully dry on 5G deployments, and even 4G penetration remains low in remote regions, one may ask why 6G efforts are necessary. Its primary focus is to support the fourth industrial revolution by building a bridge between human, machine, and environmental nodes. In addition to surpassing 5G, 6G will have a range of unique features to establish next-generation wireless communication networks for linked devices by using machine learning, ML, and artificial intelligence, AI. This will also benefit emerging technologies like smart cities, driverless cars, virtual reality, and augmented reality, in addition to smartphone and mobile network uses. It will combine and correlate different technologies, like deep learning with big data analytics. A substantial correlation between 6G and high-performance computing, HPC, has been observed. While some IoT and mobile data may be processed by edge computing resources, the bulk of it will require much more centralized HPC capacity, making 6G an essential component. Unique features of 6G. 6G networks may coexist with 5G for a while and will be a significant improvement over previous generations in several ways. This is because 6G will offer the following differentiated features. The use of new spectrum bands. Spectrum is an essential component of radio connections. Every new generation of mobile devices requires a pioneer spectrum to fully leverage the advantages of any further technological advancement. Reframing the current digital cellular spectrum from legacy technologies to the next generation will also be a part of this transformation. For urban outdoor cells, the newest pioneer spectrum slabs for 6G are anticipated to be in the mid-band 7-20 GHz. This would offer larger capacity via extreme multiple input multiple output MIMO, low bands 460 to 694 MHz for extensive coverage, and sub-THz spectrums, between 90 GHz and 300 GHz, for peak data speeds surpassing 100 gigabits per second. 5G Advanced will extend 5G beyond data transfer and significantly enhance localization accuracy to centimeter-level precision. Localization will be pushed to the next level by 6G's use of a broad spectrum, including new spectral ranges of up to terahertz. Very high data transfer speeds. 5G is scheduled to offer a peak data throughput of 20 gigabits per second and a user experience data rate of 100 megabits per second. However, 6G will deliver a maximum data rate of 1 terabit per second. Similarly, it will raise the data rate experienced by the user to 1 gigabit per second. Therefore, the spectral efficiency of 6G will be nearly more than double that of 5G. Higher spectral efficiency will offer many users instantaneous access to modern multimedia services. Network operators must redesign their current infrastructure frameworks to enable higher spectral efficiency. Ultra-low latency network functions. The latency of 5G will be lowered to just 1 millisecond. Many real-time applications' performance will be enhanced by this ultra-low latency. However, wireless communication technology of the 6th generation will decrease user-experienced latency to less than 0.1 milliseconds. Numerous delay-sensitive real-time applications will have better performance and functionality due to this drastic reduction in latency. Additionally, decreased latency will allow emergency response, remote surgical procedures, and industrial automation. Furthermore, 6G will facilitate the seamless execution of delay-sensitive real-time applications by making the network 100 times more dependable than 5G networks. Greater support for machine-to-machine (M2M) connections. While 5G addresses both human users and Internet of Things (IoT) use cases, 6G will focus more on M2M connectivity. Today's 4G networks support around 100,000 devices per square kilometer. 5G is significantly more advanced, enabling the connectivity of 1 million devices per square kilometer. With the advent of 6G networks, the target of 10 million linked devices per square kilometer is within reach. All 6G networks will include mobile edge computing, although it must be added to current 5G networks. By the time 6G networks are implemented, edge and core computing will be increasingly assimilated as elements of a unified communication and compute infrastructure framework. A focus on energy efficiency. As previously discussed, 6G networks will require stronger radio frequencies to meet the requirement for greater bandwidth. However, one of the challenges is that the foundational chip technology cannot yet function energy efficiently in these frequency ranges. Therefore, optimizing power consumption will be a key focus area for 6G developers. Currently, researchers intend to reduce the energy consumption per bit to lower than 1 nanojoule, 10⁻⁹ joules, as per the peer-reviewed paper titled, From 5G to 6G Technology, Meets Energy, Internet of Things and Machine Learning, a survey. Greater network reliability. The 5G-led ultra-reliable low-latency communication (URLLC) service will be further developed and enhanced in 6G. Reliability might be enhanced through simultaneous transmission, numerous wireless hops, device-to-device connectivity, and AI, ML. Consequently, 6G will be better than 5G in terms of network penetration and stability. In addition, 6G will optimize M2M interactions by increasing network dependability by greater than 100-fold and decreasing error rates by 10-fold compared to previous generations. The rise of new architectures. 5G represents the first solution designed to replace wired connections in corporate and industrial settings. It is deploying services-led architecture in the core foundation and cloud-native deployments, which will be expanded to portions of the radio access network (RAN). It is also anticipated that 6G networks will be implemented in heterogeneous cloud settings, including a combination of private, public, and hybrid clouds with a suitable architecture to support this. The use of AI and ML for optimal connectivity. 5G will allow artificial intelligence, AI, and machine learning, ML, technologies to achieve their full potential. Eventually, AI, ML will be implemented in various network components, network levels, and network services. From refining beamforming in the radio tier to planning at the cell site with self-optimizing networks, AI, ML will assist in achieving superior efficiency at reduced computational complexity. 6G developers, such as Nokia Bell Labs, want to adopt a blank slate approach to AI, ML, allowing AI, ML to determine the optimal method of communication between two endpoints. Advantages of 6G networks. 6G networks are anticipated to offer the following benefits. Enforces security. Cyber attacks are increasingly focusing on networks of various types. The sheer unpredictability of these attacks necessitates the implementation of robust security solutions. 6G networks will have safeguards against threats like jamming. Privacy concerns must be addressed when creating new mixed reality environments that include digital representations of actual and virtual objects. Supports personalization. OpenRAN is a fresh and evolving technology that 5G utilizes. However, OpenRAN will be a mature technology for 6G. The AI-powered RAN will allow operators of mobile networks to provide users with a bespoke network experience based on real-time user data gathered from multiple sources. The operators may further exploit real-time user data to provide superior services by personalizing quality of experience and quality of service (COS). The operators may customize several services using AI. Extends the capabilities of 5G apps. This degree of bandwidth and responsiveness will enhance 5G application performance. It will also broaden the spectrum of capabilities to enable new and innovative wireless networking, cognition, monitoring, and imaging applications. Using orthogonal frequency division multiple access (OFDMA), 6G access points will be able to serve several customers at the same time. Drives the development of wireless sensing technologies. The sampling rate refers to the number of samples obtained from a continuous signal per second, or as per an equivalent time unit, to form a digital signal. 6G's frequencies will allow for much faster sample rates than 5G. Additionally, they will provide dramatically increased throughput and data rates. Moreover, the utilization of sub-mm waves, wavelengths lower than 1 mm, and frequency selectivity is expected to accelerate the advancement of wireless sensing technologies. The network will become a repository of situational data by collecting signals reflected from objects and detecting their type, shape, relative position, velocity, and possibly material qualities. Such a sensing method may facilitate the creation of a mirror or digital counterpart of the actual environment. When combined with AI, ML, this information will provide fresh insights into the physical world, thereby rendering the network more intelligent. Inspiring new technology innovations. 6G will benefit society as a whole since new technological innovations will emerge to support it. This includes more advanced data centers. 6G networks will generate significantly more data when compared to 5G networks, and computation will evolve to ultimately encompass edge and core platform coordination. As a result of these changes, data centers will need to develop nanocores that replace traditional processor cores. Nanocores are anticipated to develop as a single computing core that combines HPC and AI. It is not necessary for the nanocore to be a tangible network node. Instead, it might consist of a conceptual aggregation of computing resources shared by several networks and systems. Saves costs through reduced software dependency. Software-defined operations are already being used by contemporary networks. Additional 6G components, like the media access control (MAC) and physical (PHY) layers, will be virtualized. Currently, PHY and MAC solutions require the deployment of specialized network hardware. Virtualization provided by 6G will lower the cost of networking equipment. Therefore, an immensely dense 6G rollout will become economically feasible. Improves cellular network penetration. Among the many advantages of 6G networks is their vast coverage area. This implies that lesser towers are necessary to cover a given amount of space. This is useful if you want to construct towers where it showers regularly or where trees and vegetation abound. Additionally, 6G is intended to support additional mobile connections beyond 5G. This implies that there will be reduced interference between devices, resulting in improved service. Optimizes indoor network usage. The majority of cellular traffic today is produced indoors, yet cellular networks were never built to properly target indoor coverage. 6G overcomes these obstacles using femtocells, small cell sites, and distributed antenna systems (DAS). Takeaway. Even as the 5G rollout continues worldwide, leading research consortiums and mobile companies are busy working on the sixth generation of mobile connectivity. 6G networks aim to connect the physical and virtual worlds through faster M2M communication and better support for immersive technology. Organizations should know about the working and importance of 6G networks to prepare for the future and fully use the wireless infrastructure available to them. Thanks for watching this video. For more information, touch with us. Comment your opinions.